recording with you so that you can recall it anytime. What Richard used to say in class, no, what video he's showing, something like that. All right. So it helps you actually is when you are doing revisions, and so on while listening to it. Okay, while listening to it. All right, and listening to it, viewing to it, and so on. It enhance or enrich your memory. Okay, and recall better, what's happening during the class, and what is being discussed, and so on. So I believe that will help. So the reason why I want to rush this syllabus, so I believe that we are this session that is very much ahead of the rest of the sections, the other sections. As I would recall that a lot of the class is still at chapter 5 or something, and we are already at chapter 6. All right, so that we have extra session later on for these final exam questions, right? So after I finish chapter 7, we will be all doing revisions, okay, based on past year questions only. All right, so we will be doing, from past year to past years, and so on, and see what's these changes, how these questions came out, how this and that, so that we can be better prepared for this final exam. All right. So even though the question haven't said yet for final exam, even though test 2 haven't said yet, we are still not sure whether test 2 will be on casting or metaforming yet. All right. So please be reminded that those that came out in test 1 and test 2 will not be features in final exam anymore. All right. All right. So we move on to this joining process. All right. So chapter 6, joining. All right. So this joining process is actually one of these more recent process. All right. Means that it just happened in this 30, 40 years, 20, 30 years, and so on. So it's a more modern type of processes in manufacturing. All right. So what you have here is that this joining process, okay, in general, okay, joining is an all-inclusive term, okay, means that if you join something, that is joining process, whether it's by permanently or non-permanently. All right, like for example, if you will actually bind some of your notes, okay, some of your notes that you copy from, let's say, my class, into let's say a file, okay, that is a joining process because you are using another material to join papers together. Like for example, by using stapler, you are using a metal hinge or something, the bullet in the stapler, to basically use a metal to join paper. Okay, so if for example you are using glue, okay, adhesive, to actually glue the caustic, the glue, that put the back of the paper and then join, and stick them together, and so on. Those are joining process. Not necessarily metal joining metal, the more sophisticated, like, welding process that is joining. No, other than that, you can have papers being joined together, how the glass is being glued or being stick on your screen of your smartphone, for example, your touch screen. Those are metal. Those are no, glasses. All right, being joined onto a aluminum casing, and so on. Okay, like for example, this they use this kind of clip, and so on, like the back casing of the phone previously you have on the models. Still remember the days whereby we still can change the battery. We still can open the back lid, and then we change the battery, immediately you get 100% full charge, and so on. I miss those days, to be frank. Okay, I don't have to carry around, power banks, and so on. So immediately open the back casing, put in a new battery, now 100%. Save the trouble of charging. I don't have to find, places, plugs, and so on, and bring all those cables, and so on. I just bring extra batteries. All right. But those were the days. But I still wonder why they don't want to do this. All right. Maybe it's for the IP rating things. Like for example, this water resistance, waterproof. If you have this if you can actually open up the back lids, it actually it makes the waterproof or water resistance more complicated or unable to do it at all. All right. So in this joining process, it covers processes such as welding, brazing, soldering, adhesive, like I say, the using of glues, and the mechanical fastening. Mechanical fastening is, for example, like bow and nuts, screw, and so on. All right. And many of the market available process were made by assembling of various components, like for example, your car engines, especially in your cars, right? The car doors, the car window, the tire, the whole engine, the motor, the fan, and then the aircon unit, even though your seat actually is being put there, through joining, you can see a lot of evidence, in the products, whereby the thing is being joined together, either permanently or non-permanently. All right. So you have this kind of various components, parts, subparts, sub-assembly, and so on and so forth, being joined together, like your dashboard, your steering wheel, your pedal, your handbrake, your gear, and so on, all are being joined, produced separately and joined, okay, onto your car body, even though for motorbikes, even though for your house appliances, air cons, fans, stand fan, and washing machines, all those work. The process, all these results of joining, okay, to make things happen, to make things possible. If not because of that, okay, then a lot of our product has to be produced in one piece, okay, then it will limit our freedom of using something, will limit the function that we can have. Now imagine the whole smartphone has to be made in one piece. Now that would be very interesting. Considering how are we going to assemble something of different material nature? Now, either it has to be all metal, either it has to be all plastic, either it has to be all glasses, or ceramics, and so on. Now, how would that be possible when you have material of different nature actually work differently with different functions, and so on? So how would you assemble that together? If not because of a joining process. Okay, so these processes are an essential, it's very, very important in makes, the manufacturing today is possible. All right, and important aspect of manufacturing and assembling operation. Okay, so for some of the reasons, all right, that this joining is very important. All right, so this actually came out in the final exam before. Okay, owing to what reasons make joining process an important process or being selected by this industry? It's because of this. Okay, there are five of them. There are five of them, and then the first one is product may be impossible to manufacture in one piece or one single piece. All right, for example, an aeroplane, a car, a motorbike. How can you produce everything in one piece? One solid piece, it's like one block of metal. How can you do that? Even you can do it, but it's not advisable for you to do it because of the reasons below. Okay, the third one especially. Okay, the third one especially. So we'll come to that. All right. So it's rather impossible or not advisable to make it into one piece or to make into one piece of product, one solid piece. All right. Can you imagine you have one piece of car, not a car, a piece of car. The car is in whole unit, one unit only with no screw, no bolt, no nuts. Okay. So how are we going to go to manufacture the engine then? There are moving parts. Okay, how will you actually produce a moving parts in one solid piece of metal block, for example? Like, for example, your combustion engine. Your piston will be moving up and down, up and down, up and down, and then your shaft will be moving, and so on. How are we going to even manufacture that? It has to be separated to allow that to happen. All right. So if that's the case, now car is impossible. Okay, or even though your smartphone is impossible, okay, to produce. All right. So the second one is that the product is more economical to manufacture through assembly. Well, even though if you can actually do it in one piece, it would be tremendously expensive if you want to do so. Probably you need to, like, for example, produce it with a 3D printing, for example, something like that. The tremendous genius in design actually has to be involved, okay, so that this thing is in one piece, yet this is movable, okay. So rather, not to say impossible, it will be tricky, and maybe there will be some limitation in the freedom of movement, okay, or the freedom of the design actually will be hindered or will be affected. All right. So the third one is the product has to be taken apart, right? So this is the main reason. The product has to be taken apart once in a while or when needed. For example, when you are doing maintenance, right? When you go for car maintenance every now and then, so to change the engine oil, to change the oil filter, or to do repair, my boss, my aircon is not so cold. Yeah, the boss will tell you, okay, let me check. Okay, your fan is having problems, your motor is having problems, and so on. So they change a new unit, something like that. Or they can open it up and do repair service, and so on. All right. So when your tire actually is flat, and so on, so it can actually be removed for further process. All right. If everything is made into one piece, it would be very difficult or impossible to actually do a replacement. Anything. Now, let's say if you can make a car in one piece, having any engine problem, sorry, you have to change the whole car. Now, how to disassemble it, how to change or fix the engine unit if everything is in one piece. So you have to actually go through the joining process so that I can take off the screw bolt nut or mountings, everything, and remove the engine or even change the new engine in or to repair the engine. All right. So it says here has to be taken apart for maintenance or replacement of parts or even how to say recondition it, and so on. All right. So number 4, different nature or properties of material may be desirable to assemble together for functional purposes of the products. Like, for example, your Godzilla glass screen on your smartphone. Now, we can't replace it with something else. Maybe in future, who knows? I don't know. All right. But at present moment, that is the best option that we have. Okay, so that we are using glass screen and then on a aluminium body, so that it actually because of the different nature or function and the electronics, things, the circuit boards, the resistor, transistors, and so on. Those were rare earths. Okay, those were rare materials, ceramics, and so on. All right, so we can't use metal as let's say our processor. Okay. In future, I don't know, but at present, the nature of this thing can function basically is different. All right. So we need to have the alternative or this material of various sort. Okay, because every material, as we know, has a different nature. Some are very good to transmit electricity. Some is a very good conductor. Some is very good in strength. For example, the smartphone body or the car bodies, and so on. So even metal, you have different grades of metal. How can you fuse, okay? Or how can you melt, and a different metal, and then I want a certain part to be this kind of alloy, a certain part to be that kind of alloy, and then yet it is in one pieces. That would be very difficult because once you melt everything, it will be homogenized. It will become homogeneous, uniform, similar nature, right? So it would be very difficult. And moreover, you're talking about mixing materials, like for example, in a car, right? The car cushion, your seat, okay, has to be fiber, okay, or leather, okay, or something soft that you can sit on. The car body has to be hard. You can't build a car body that is soft, it would be very dangerous, okay? And then some of the material has to be plastic. Now, I know back then a lot of these plastic parts actually were metal back then, all right? But it would actually add weight to the car and make the car heavier. Then the fuel consumption will be affected. Your car makan minyak lah, senang kata. So the fuel consumption is high, means that you have to fill in petrol, more oftenly. Okay, your mileage will be affected. Okay, means you spend more money on petrol. Now that would be very how would I say, a very bad marketing, right? But nowadays when we talk about cars, especially in Malaysia, we are talking about how many kilometers, one can this car can go with 1 liter of petrol, something like that, or there are 10 kilometer, or or maybe say, okay, the other brand got 30% extra than yours. Similarly, the design is quite well. No, nowadays when you talk about this kind of economical car, like for example, like Axia, like Myvi, like for example Honda City, Toyota Vios, those kind of car. We are talking about the greatest strength. Greatest strength of it is the mileage. Other than that, of course, the car strength, safety, comfort, and durability. That one is very much important. Okay, it's very important as well. We do not want a car that is made of paper and then it can go 100 kilometer with 1 liter of fuel. Yeah, I know, but look at the car. It's not safe at all. It's made from paper, for God's sake, right? So we do not want that as well. So we can't sacrifice everything just to achieve something. Okay, all right. So this manufacturer is basically looking for ways to actually improve the material, to improve in every sense, okay, in terms of products to make things work. And nowadays, they even build in with a lot of electronics, right? For example, the in-car GPS system, the AI in the car, okay? So I believe that, okay, one day, okay, we'll have sufficient AI, okay, that is good enough. When we enter the car, we just okay. So when we enter the car, just like Tony Stark's, Jarvis, Friday, and I don't know which one. There's another name, right? So it's the AI system, right? So he will always, the AI will always address, Tony Stark as sir, and so on. Where are you headed? Something like that. How are you, sir? And so on. Like Tony Stark will always ask, give me the damage report, something like that. Okay, and maybe if you be precise enough to even aid him in firing his missile, and bullets, and so on to the enemies. But of course, that is CGI. Okay, that is in the movie. But one day we are going to move towards that. I believe, because nowadays, when I look at that, I would say, this kind of AI is what I always wanted. Like for example, in this Spider-Man, okay, have you anybody watched the No Way Home? Okay, I'm going tonight. All right. All right, I'm going to the cinema tonight. So for that, and I always wanted, for something like, you're wearing a spectacles, and so on, specs, if I'm not mistaken, the name is Edith, EDITH, the AI, okay, that can control so many things. You have this authority, something like passwords, and so on. They can sense your eyes, and so on, and then you can give command to it. Now imagine if you have a car, you go into your car will talk to you. Where are you headed to today, sir? Then I can just tell him work or office. Then the car will drive by itself, and then I can enjoy my sleep during the journey. Okay, so when the car arrives, it will tells me that, sir, we already arrived, or destination approaching in 5 minutes, something like that. Okay, that would be the future generations. All right. So because when we talk about 30 to 50 years ago, when everybody talks about like movie like Star Wars, and so on, those kind of science fiction movies. Okay, now back then we don't even we just have something called the telephone, all right, and telephone with the line, and so on. And the telephone is quite huge, and nowadays we are talking about supercomputers in our hand, in our palm. That is our smartphone. So who said that it can't be made? All right, just we were limited by the technology of our time. All right, so that one day, who knows, right? So with all this manufacturing, basically the humans are moving forwards. All right, all right. With the last thing is the ease of transportation. Now, when you can disassemble, take off everything, so things can be shipped or can be moved around in terms of spare parts, or in terms of sub-assembly, in terms of parts, in terms of components, rather than the whole product. Okay, so in some products, it might be too huge to actually ship in the whole complete unit. For example, the aeroplanes, parts, and so on. It would be very difficult, to actually move around. All right. Like for example, I can take off the engine and only ship the engine. Yeah, rather than I'm having some trucks, and actually shipping the whole plane. Now it would be impossible to do that. Okay. So in Boeing 747, the Airbus, they rather, they complete the product at their site, and then they fly the plane over to, let's say, to Malaysia, and give to Mars, they give to AirAsia. Nah, this is your plane. Okay, so they fly it over here. All right. So some of these parts is rather too huge. Like for example, this giant cruiser. Okay, how are you going to ship that? Rather than I rather finish the whole cruiser, and then I'll sell it to you. Okay, all right. So let's look at some one of the video that I intended to show you. All right. So about this joining. Okay. 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 Oops. It's in Hindi. Okay. All right, we'll go to welding first. Okay.
Hi everybody, it's Scott here. This is the first video in a series looking at different joining methods in engineering applications, and in this video we're going to take you through a bit of an introduction and an overview of the different joining methods that we have available to us as engineers, and we're going to explain the different examples of welding that we have access to typically in industry. Let's start by taking a look at the overall chart that we have that captures most of the manufacturing methods in the different categories. So we have forming methods over here, the main one being sand casting. We have machining methods, including turning, drilling, and milling. And in this series of videos, we're going to take a look at the joining methods, which might include things like welding, screws, rivets, splines, and keys. These ones down here. I've got a little bit of a different way of looking at this, so I'll go to this next slide. And so this is a way of categorizing the different joining methods available to us. We can split them all up between permanent methods or relatively permanent methods. A lot of these can be undone with a bit of work, but not very easily. And then we have the temporary methods on this side of this Boolean tree. Underneath the permanent methods, I've divided them into two separate categories, those that are joined using liquids. So this might include welding, brazing, soldering, and also the use of adhesives. And then on the other arm of this category, we have plastic joining methods. So I'm not talking about plastics. What we're talking about here is plastic deformation of our materials to enable them to act as joiners. So things like riveting, staking, forming, and swaging are all ways of joining two components or two materials together by plastically deforming those materials. If we look over at the temporary side of the tree, we've split them up into threaded and non-threaded fasteners. So under the threaded fasteners, we have common things like bolts and screws and studs and nuts. And then in the non-threaded category, we have options such as pins and keys, splines, clips, and interference fits. So this is the way we've chosen to categorize the different methods, and we're going to work through them in this basic order now. So we're going to start off by looking at a variety of different welding processes that we have available. In general terms, to create a weld, the interface between two solid materials is melted. These liquids from these two materials are mixed together, and then they're allowed to solidify. Sometimes we can also use a third material, such as a melted rod or a wire, that we can add to this weld pool to actually increase the amount of material there and to help form a stronger joint. This is an optional thing that we can do. So what do we have to think about when we're creating our welds? Well, first of all, the materials have to have approximately the same melting points. So for instance, we couldn't try and weld lead to steel because lead will melt at a much lower temperature and the steel won't even be getting soft yet. And so the lead will all run away before the steel has got to the point where it will melt. So we couldn't do that. The materials must be able to mix, so you might have an example where you're trying to weld lead to plastic. If you look up the melting points, you might find they're very similar, but because these materials are so dissimilar, they won't want to mix together happily, and so we're not going to be able to create a workable weld between these two materials. The material properties near the welded zones may be affected by the heat which we've added to create the weld. This is something that we have to keep in mind when we're welding things. For instance, if you have some hardened steel that you're welding, that hardened steel may have been hardened by a process of heat treatment, and by welding it in the region around the weld, the different cooling rates when it's being welded and solidifying may actually change the material properties. So it could potentially become softer. It could also become harder in that heat-affected zone and actually become more brittle. So this is something that we have to be aware of and do some research on the materials that we're welding together to ensure that we're not altering those properties in a way that might be detrimental to the final component that we're building. Another thing that you should keep in mind is that any coatings, such as galvanizing that we might have on steel to stop it rusting, these coatings must be removed before we can weld them in order to create an effective join. So if we were to try and weld with the galvanizing on the steel, then that gets into the weld and causes impurities, which we don't want. It can weaken our weld. We should also be aware that some metals like aluminium, they have a strong oxide film on them pretty much all the time. And in order to weld the metal underneath, we need to get through that oxide film. And so we have special techniques and special welding technologies to be able to do that. We should also be aware that the chemical composition of this weld pool, the melted metals, may be affected by exposure to the atmosphere. So if we have some steels and it may have a certain amount of carbon in it, if we melt this, the carbon may come out of the steel and form CO2, and so we'll have less carbon in that area of the weld than we otherwise do, and that could change the material properties in the weld. These are all things that we need to think about and keep in mind when we're designing our welds. Let's take a look at a few different practical examples of how we weld metals together. The first one we're going to consider is oxy-welding, also called oxyacetylene welding sometimes, or oxypropane welding. And what we do to create welds using this technique is to generate heat by burning oxygen with a combustible gas such as acetylene. You can see the guy on the left in this picture, he's got his glasses on there, so his eyes aren't exposed to this bright light of the gases burning, and he's using this torch which mixes the gases together with oxygen, and there's a flame at the bottom which has a nice tight shape to it so he can direct the heat accurately, and he's melting metal, and in his left hand here he has a filler rod which is allowing him to add extra material to the weld as he goes. So we can use this technique. It's quite fine, and it can be used to weld thin to thick pieces because we can direct the heat where we want it to go and put more heat into the thicker piece and prevent the thinner pieces from melting away. That's one of the advantages of this technique. It's also something that we can do underwater. So if you get this combustion going, you can actually do it with surrounded by water, and even though you're losing a lot of heat to the water, if you stick at it, you can actually get the required amount of heat into the metal and actually weld underwater. And this guy is a very specialized technician and gets paid a lot of money to do that on offshore oil rigs and the like. We can also adjust the balance of oxygen and acetylene in our mix to allow us to either add or remove carbon from the different steels that we're welding. So this is a further option we have with this technique, which is useful to ensure we get the final material properties in our weld that we desire. Another common welding technique is called arc welding. And in this process, we use heat, which is generated by an electrical arc between an electrode, which is part of the welder, and these materials that we're welding together to melt the material. So in this image on the right-hand side here, we have a typical small hobbyist size arc welder, and we would put an electrode into this side of the handle, and this is our earth lead, which we connect to the part that we're welding to complete the circuit. And then when we turn it on and we strike the arc, we create an arc here, and that progressively melts our electrode, and that electrode contributes material like a filler rod to the weld as we go along while sustaining that arc. On the outside of our electrode, we have commonly a coating, and this coating melts due to the heat, and it forms a slag layer which helps both prepare the metal surface and also protect the weld metal when it's still molten from the atmosphere, so we can keep out some of the impurities and the loss of the carbon that we might otherwise see from exposure to that atmosphere. Unfortunately, we don't have as great a control over where we direct the heat using this process, and so we can't as easily weld thin to thick pieces, so there's a limit to the difference in the sizes of parts that we can weld together, and typically we use this technique for quite heavy industrial parts like 5 or 10 millimeters thick or bigger. As I mentioned, that electrode coating on the outside helps prepare that surface of the weld and also protect it against exposure to the atmosphere while it's cooling. Once the weld has fully cooled, if we want to expose this weld and perhaps do another pass of weld, then we actually have to chip off this slag layer once it solidifies with a hammer and make sure we've removed all of that before we do the next pass on our weld if we need to build up a lot of thickness. We can also use a similar process, but rather than having a slag layer that protects the weld, we can shield our weld pool by pumping in an inert gas and making sure that's enveloping the weld as we're welding. Typical names for these techniques are either MIG or TIG. This is a MIG welder that you see here. A MIG welder is differentiated by the fact that it has a roll of very thin wire here, which is fed all the way through to the gun here, and so that is like a continuous arc welding technique, and the wire actually moves quite fast and sustains the arc and is consumed at the same time. And then we shield that by hooking this up to a gas bottle, and then we pump gas through this as well, and so that gas surrounds the weld when it's very hot and prevents that oxygen getting in there. TIG is another option, but in TIG we don't have the reel of wire that's constantly fed out to the gun. We have a tungsten electrode, which is used to sustain the arc, and that's not consumed. And then we periodically dab in, if we need it, some filler rod as we go, and then we have the argon gas shielding this whole process as well. It's also quite common in industry to see robots performing these welding techniques in modern mass production. So that's MIG and TIG welding, which are variants of arc welding. The third common welding technique is called electrical resistance welding. So in this example, we take typically pieces of steel. So we have two pieces of steel in the center here, and then we have an electrode on either side, which we clamp up with a lot of force to ensure that this is all compressed together and we have a good contact going through all of these bits of material. And then we run a high electrical current through this assembly basically. And given that these electrodes are made from copper and they have a lower resistance than the steel, the large electrical resistance occurs through the steel, and that generates a lot of heat, which then melts these two steel plates together. This is commonly called spot welding. So the heat in this circumstance is generated by our I²R electrical power relationship at this interface between the two materials. They then melt, and given the differences between steel and copper, the copper doesn't actually get stuck to the steel, and we can pull that away and it doesn't actually get welded together. We need to ensure that we've got high force here because these plates might not perfectly align, and we need to have a good electrical contact through here. So the machines that do these spot welds are quite big and robust, and they typically have a powered clamping mechanism to hold this together quite firmly. And it's used quite commonly in the automotive manufacturing industries, where they have people and even robots which can create these spot welds at very precise positions on the car in order to join all the different body panels and floor panels together in a highly efficient production process. There are a few other variants on this theme of spot welding, and one of them shown here is seam welding. So rather than two single electrodes being pressed together, we have two rollers and they roll continuously, and then if we feed in our sheets of material here with an overlap, then that will be continuously welded, seam welded together. And another variant of that again is slightly different, called mash welding, where we try to eliminate that overlap by squishing them very hard together with minimum overlap. Those are the three most common types of welding that you'll experience in industry, and hopefully this video has given you a little bit of an insight into the differences and the things that we need to consider when we're designing for these different welding processes. Thanks for watching.
Hi, this is Professor Ko.
Okay, so this is one of these welding or joining method through welding. All right. So this joining process basically is joining things in a permanent way. But of course, in a permanent way, you still can remove it. All right, you still can, but it requires harder effort, and so on. So that's one. All right. So we look at another video. So I found this video about these introductions of the joining process. So we'll go through it. So we'll go through. So in this the video just now, it mentioned a lot of processes, right? So don't worry about that. That's only the bird eye view. Okay, you have this. Later on, we'll go in process by process. All right. So those important ones will be highlighted. All right.
你的课程卖不出去，卖得不好吗？那就不要再介绍你的课程内容了。如果你课程的销售成效不佳，
Hello my dear learners, welcome to Introduction on Joining Process. In this lecture series, you will be learning about joining processes. There are some products which cannot be manufactured as a single piece. Such products can be obtained by joining two or more parts. For example, aircraft, ship bodies, and all other parts which are very huge are fabricated by joining. So it is classified based on the type of joint as temporary joint and permanent joint. A temporary joint can be easily dismantled, separating the original parts, whereas the permanent joints cannot be separated to their original shape, size, and surface finish. Joining processes are further classified into soldering, brazing, welding, mechanical fastening, and adhesive bonding. Majority of the mechanical fasteners are used for temporary joints, rivets for semi-permanent joints, and welding for permanent joints. Brazing and soldering are considered to form permanent joint, but for repair or replacement, these joints can be dismantled by gating. Welding is one of the most extensively used fabrication methods, but the joint strength obtained is equal to or sometimes more than that of the parent metal. There are certain parameters that you need to select while choosing a joining process. It is application, nature of loads or stresses, joint design, materials involved, and size and shape of the components.
Okay, just now this introduction, and the previous even the previous one, the one before the last one is about the welding permanent joint. So this is about the mechanical fastening. So why I want to show you these three categories because of this chart here. So here it mentioned that in joining process there are three major categories. One is by using glue or the adhesive method. So whatever the Yuhu gum, the glue, and all sorts of industrial glue, and so on that you use, okay, is involved in this category. Okay, the welding, okay, and under the welding, you still can see there's a lot of subcategory by fusion, solid state, electrical, resistance, and so on and so forth. We will cover each and every one of these throughout this chapter. And also the mechanical fastening, which is the bolt and nut, screw, stapler, and so on. Okay, so we move back here. All right, so in this is about this mechanical fastening. Just a bit like what I will just a very quick one. So enjoy.
Hello friends, welcome to the Drive the World channel. Let's see the process of joining the plastics. There are several techniques for the joining the plastics. Equipment cost and labor for each method vary considerably. Most of techniques have limits on the size and types of plastic that can be joined. Types of the joining plastics. First is mechanical fastening. Second, fusion bonding. Third is hot gas welding. Fourth is vibration welding. Solvent bonding, ultrasonic welding, induction welding, dielectric welding. Let's discuss mechanical fastening. The simplest way to join the plastic parts is to design a fastening element, hinge, latch, detent into the part. Only stronger plastics are suitable for this method. Joint must have survived the strain of assembly, service load, and possible repeated use. This form of fastening is suitable only for lightly loaded, no rigid assemblies where precision is not critical. Mechanical fasteners, screw, rivet, pins, sheet metal, nuts are the most common joining methods. They require a plastic that can withstand the strain of fastener insertion and subsequent high stress around the fastener. Conventional machine screws are rarely used except with extremely strong plastic. There are number of fasteners designed for use with plastic. Threaded fastener work best on thick section. Thread forming screw are preferred for soft material, while thread cutting screw work best on hard plastic. Push-on lock nut and clips may be better for thinner sections. If a fastener has to be removed a number of times, metal inserts are recommended. They may be molded in place, forced, glued, or expanded into the hole, or inserted ultrasonically. There are two main categories of industrial fastener, permanent and non-permanent. Screw are example of non-permanent fastener since they can be removed, replaced and reused. Failure is normally a result of cracking or creasing due to tensile stress that can be induced under the high pressure. Compressive stress is much more desirable due to the lower susceptibility to localized stressing, cracking. Use screw in mechanical fastening as per head design, washer type, hex and square, filter, truss and pan head. As per first image, to fastening the part with screw need to provide boss between two surfaces and also use standoff according to application. In shown picture, don't use the circular hole to fastening two part. If we provide oblong shape at one side and other side oblong shape, the fitment will be correct.
Hi everyone, this is Grace, and today I
Adhesive bonding, like welding, provides a distributed means of transferring load from one part to another. We can eliminate the stress concentrations induced by fastener holes and spread the load transfer out more evenly over the joint, making it a very attractive joining option. However, rather than relying on the melting and fusing of the parts as with welding, adhesive bonding uses an additional material to glue the two parts together. This can eliminate some of the material restrictions encountered in welding, but introduces its own set of challenges to deal with. An adhesive bonded joint relies on an adhesive material to join the two parts together. If we look closely at how this adhesive material connects to the parts it is joining, we can see that two different mechanisms for transferring load come into play. First, the adhesive material forms a chemical bond with the part it is joining. These chemical bonds and their strength will be dependent on the bonding process and the compatibility of the adhesive and joining material. Second, the adhesive material will flow into the nooks and crannies of the microscopically rough surface to be joined. The adhesive will then mechanically interlock with this surface roughness, allowing some load transfer through mechanical interlocking. Realizing this, let's take a closer look at the possible failure modes of an adhesively bonded joint. If we zoom back out from the joint and think about how such a joint can fail, it is possible to envision three major categories of failure. If the load exceeds the strength of the material being joined, you have failure in the joint material, known as adherent failure. Like with mechanically fastened joints, this is a desired failure mode as it means the joint is sufficiently designed to reach the strength potential of the structures it is joining. If the load exceeds the strength of the adhesive, then the adhesive material can fail. This failure mode is typically referred to as cohesive failure, as the chemical bonds that hold the molecules together within the material are known as cohesive bonds, and it is these bonds that are overcome to cause the failure of the material. This failure mode is limited by the strength of the adhesive material. Conversely, if the chemical bonds that glue the adhesive material to the part being joined are overcome by the loading, failure can occur along the interface between the adhesive material and these parts. This failure mode is known as adhesive or adhesion failure and is limited by the quality of the chemical bonds formed during the bonding process. This failure mode is not acceptable for aircraft structures, and if occurs, it is a sign that there were problems with the bonding process itself. It is important to understand the basic steps within the bonding process in order to understand the potential risks for adhesion failure in a bonded joint. If we start with the two parts to be joined, the first critical step is to prepare the surfaces of the parts. This surface preparation step can involve one or more of the following: increasing the roughness of the surface using an abrasive material such as sandblasting, cleaning the surface using industrial solvents to remove any grease or impurities, and using a chemical process to activate the surface of the part, making it more prone to form chemical bonds with the adhesive material. The next step is to apply the adhesive material to the parts to be joined. The adhesive material can come in many forms, including an adhesive film or paste that can be applied on the surface of the part. Once the adhesive is applied, the parts can be assembled and temporarily held in place with some form of clamps or fixtures. This is an important step, as the adhesive cannot carry loads until it has fully cured, forming all the necessary chemical bonds with the surfaces of the parts. The final step is the curing step. In order to speed up this process, it is common to apply heat and pressure to the part, which will accelerate the chemical reaction within the adhesive. In aircraft manufacturing facilities, you will often see large pressure ovens known as autoclaves, which are used for curing adhesively joined parts and composite materials, which are essentially adhesively bonded structures. From the description of the different steps within the bonding process, it should be clear that the surface preparation step is vital for ensuring the quality of the bond. Impurities and insufficient activation of the surface to be bonded can result in a very low adhesion strength of the joint, which is unacceptable for aircraft structures. Unfortunately, one of the challenges we face in the aerospace industry is that the pretreatment processes we use tend to involve toxic chemicals that are not good for the health of workers or the environment. We are constantly trying to find more environmentally friendly options. However, these tend to have a significant reduction in performance. The second major challenge is that the repeatability of quality in the bonding process. You might have inadvertently encountered this before if you have ever used adhesively backed sticky notes. If you put a number of sticky notes on a wall, being sure to try and repeat this process in the same way for each note, you will notice over time one or more of these notes may fall down. It is easy to say that contamination or small variations in the process resulted in the premature failure, but predicting which note will fall first and when it will fall is extremely difficult. This inability to precisely predict when failure may occur makes certification of bonded structures very difficult for safety-critical structures. So adhesive bonding is a chemical process that can result in a very efficient structural joint, but is susceptible to pretreatment and processing variations. Although as engineers we would like to exploit the efficiency of bonded joints much more, in practice, the challenges associated with process variations make it very difficult to make widespread use of the technology for primary structural joints.
Introducing Speechula, the most natural.
All right, some of you, my question, like for example, how strong can an adhesive bonding be? Now, will it be better than a permanent joint in welding? Or will it be even stronger than mechanical fastening? Now, owing to the more recent or modern manufacturing development, R&D, and so on, you will be surprised to find out that a lot of your household decorations, and so on, and interior designs, and so on your kitchens and in your like the kitchen cabinets, and so on, were actually being done without the use of any permanent joint. All right, it's being placed there by using adhesive or glue, and so on, and even tape. All right, like let's look at some of these products that is available.
Mado's nail-free glue. Application. The following: skirting lines, wooden floors, photo frames, tiles, mirrors, marble walls, add words, door frames. Application introduction. Cut the nozzle, poke the tin foil, install the glue into the gun. Clean the construction surface to ensure no oil and dirt. Settle on the right position. Spread the nail-free glue evenly on the back of the fixed rod. Stick it on the wall. Press hard for 2 minutes. Observe whether it slides down. Stick an auxiliary sticker on a fixed position and use it after 48 hours of drying. Mado's nail-free glue super adhesion.
Of course, when we are talking about this strength of this thing, it's like, now it's not basically designed for heavy duty usage. For example, like a moving mechanism that repetitively has to go through a cycle of let's say stampings, and so on. For those stamping machines, and so on, maybe glue might not be that appropriate. But for example, this like this kitchen towel, hanger, and so on. Now it's used to hang like towels, like your cooking pans, and so on. That might be just a few kilos of weight, a few hundred grams, and so on. It might just do the tricks, okay? Serve the purpose of having enough, more than enough, or more than sufficient strength to actually withstand this weight, and it justifies the usage, all right, of the purpose of it, the functioning purpose. No, you do not actually hang something that is extremely heavy. Now, for example, in this case, you can see that this human, this person is actually hanging there. So it's just telling you that, okay, that this particular joint can withstand a weight of let's say, a human, right? But I'm not sure whether if you hang there for, let's say, a few days, months, and so on, it will still last, or it will still stick to the wall. Now, this one I'm not too sure, because once in a while, if you're at home, some of the things did actually peel off, and so on over time. But actually, when you actually, what's the fuss about it? You just can glue it back and then you stick there for about 24 hours later, it still be as good as new, right?
Disassembly method. Use a hairdryer to heat the bonding area for 4 to 6 minutes. Move up and down slowly, then take down the shelf. Scrape the wall and clean with a rag.
So here's another one. I got this at home. So I've saw this in this Facebook advertisement whereby they use this kind of adhesive tape to actually seal off, like for example, leaking pipe, and so on, or broken, let's say the containers, and so on, by using adhesive. And it's quite impressive. I'm not actually promoting or selling this brand. I didn't get any commission from doing so, but just I feel that this is impressive, because I myself I bought a few of them. So in case there's anything leak in my house, and so on, I just cut a small pieces and stick on it. That's it. Okay, and it solved the problem. All right. Of course, changing a new one would be good, but sometimes not everything is require this kind of action. All right.
Hi, Phil Swift here for
How come the sound is off? My laptop's actually got Google Meet actually got bumped out from this Google Meet, so I'll rejoin and then I'll share again. Sorry about that. Okay, I'm back. All right. Okay, let's start again.
Hi, Phil Swift here for Flex Tape, the super strong waterproof tape that can instantly patch, bond, seal, and repair. Flex Tape is no ordinary tape. Its triple thick adhesive virtually welds itself to the surface, instantly stopping the toughest leaks. Leaky pipes can cause major damage, but Flex Tape grips on tight and bonds instantly. Plus, Flex Tape's powerful adhesive is so strong, it even works underwater. Now you can repair leaks in pools and spas without draining them. Flex Tape is perfect for marine, campers, and RVs. Flex Tape is super strong, and once it's on, it holds on tight. And for emergency auto repair, Flex Tape keeps its grip, even in the toughest conditions. Big storms can cause big damage, but Flex Tape comes super wide, so you can easily patch large holes. To show you the power of Flex Tape, I sawed this boat in half and repaired it with only Flex Tape. Not only does Flex Tape's powerful adhesive hold the boat together, but it creates a super strong watertight seal, so the inside is completely dry. Yeah, doggy! Just cut, peel, stick, and seal. Imagine everything you can do with the power of Flex Tape.
All right, we are back in our notes. All right, so that's adhesive bonding. Okay, so that's the categories of this joining that is available in this manufacturing. Okay, one is by using the permanent method, which is the by welding process. All right, welding. Okay, and then by mechanical fastening with the use of bolt nuts, and so on, that we can take off. Okay, we can actually remove the parts, like for example, to meet the requirement or the reasons of why we need to have joining. It's like to repair, to do maintenance, change of parts, and so on. All right. So ease of transportation. All right. So and then we have this screwing. Right. So, like for example, how this our screen, okay, of our smartphone is being put on a metal casing, okay, of our smartphone. Okay, one of it is by adhesive bonding. Okay, so whereby all the adhesive, and so on is being placed under the glass, and so on, so that it stick to the metal casing of this smartphone. All right. So how did all these uh, let's say these circuit boards, and so on is being put together in a smartphone? It's by bow and nuts, screw. Okay. So all of this is by using this joining method or the various kind of joining methods to put everything together into one piece, despite of the nature of the material. Okay, the nature, the type of the material can be different, the nature can be different, the function can be different. So everything is made possible to put into one under a device called smartphone. So you have thousands of components being joined together. So we'll go through this joining process, various joining process on how this is possible, right? So in another words, without this joining process, okay, amazing product is actually will be limited. I mean, a lot of things. Oh yeah, we cannot join. Oh yeah, we cannot do. We have to make everything in one piece, and so on. That would be very, very much impossible if you want to do everything in one piece, like I mentioned just now. All right. So there are various process. There are various category of process, which is in each of the categories. So there are subcategories. All right. So the first one we have to go into, or we will go into, is the fusion welding. Right. Fusion welding basically is by the use of heat. Right. All right. So heat is applied, as I mentioned here. Heat is applied to soften and melt the material surface, and then flows into the joint. Extra material, sometimes we use filler. The philosophy is just like the soldering process. When you are doing solder, you put the soldering element or the filler, okay, and so that it will take out the material and then do the joining. Okay, so sometimes it's with filler, sometimes it's without filler, depends on the necessity of it. All right, so all shapes is possible. All right, so because this is a fusion welding permanent, so it's only applicable to metal, right? So they can be used for all material that can be made to soften. So in other words, that can be melt. All right. So and then flow without chemical degradation means that after it melts, it solidifies without losing its characteristic, either physical, chemical, or mechanical properties. It will stay the same. All right. But however, you have to be aware that if you are melting the particular parts of this material, all right, so there will be some amount of oxidation that will happen if without taking care of it properly. There will be an amount of oxidation that will happen, as you know, oxygen is the cancer of any metal, any oxide, and so on. It will weaken the products, it will weaken the materials. Not to say the end of the world, we can do something else to prevent it or to reduce it. All right. But however, you must be aware that this thing actually happened or this thing actually take place. All right. Okay, so this is an overview of what a fusion welding is. All right, so what is the fusion process? All right, so we look into fusion welding. Okay.
Hey guys, welcome to SkillLink. If you're somebody from India, you would have seen metal working shops on the roadside. Most of the time, a worker would be hunched over a metal.
I think most of you have already seen this before. It happened especially in this construction yard, and all those like making this extra aluminium roof, and so on, or this whereby these people actually squat there, and holding a shield, and creating this kind of sparks. Okay, so I believe this is not new to all of us. All right, so this is a fusion welding. It requires electricity to generate the heat as the power source to generate the heat. All right.
Metal bar or rod. A very bright blue light emits from the metal. The blue light is nothing but heat from welding, and this is our topic for today. Around 50 different types of welding operations have been catalogued and recognized by the American Welding Society. We can divide welding processes into two major groups: fusion welding and solid-state welding. In this video, we'll be talking about the fusion welding process in detail. The fusion welding processes use heat to melt the base metals. In many of the fusion welding operations, a filler metal or material is added to the molten pool of metal. This is done to increase the strength of the weld joint. However, all fusion welding processes don't use a filler material. Such processes are called autogenous welds. If the material of the filler is the same metal used for the parent material, then it is called a homogeneous weld. If the filler material and the parent metal are different, then it is called a heterogeneous weld. In this video, we will have a brief discussion on the different types of fusion welding processes, and then we will discuss in-depth working of each of the welding types. The first type of fusion welding process is the arc welding. Arc welding refers to a group of welding processes in which the heating of metals is achieved by an electrical arc. Some arc welding.
Okay, you can see this stick here. So this is a consumable stick there. So in this arc welding or this fusion welding method, so this stick here will become shorter and shorter and shorter because it melts. Okay, so I'll discuss that in the note section later on. All right. So this thing is consumable. Okay, whereby this thing actually holding a torch, holding this stick, and it is being connected to this power source. So the power source will generate enough power so that it will flow, the electricity will flow through these tips. And then when you are approaching this, let's say this workpiece, it will create a spark. Means that the electron will jump from these tips to the parent material. All right. So the philosophy, it works something like the spark plugs in our car, whereby the charge is being forced to jump from one tip to another surface and then created the heat required. So in the end, the higher the power or the higher the voltage being set for this process, the more of the charge is going to jump from one tip to another. So it will create even more heat. So in the end, how much power is required, how many voltage is required, depends on what material that you are welding. Okay, too much sometimes is not good, because what if you are facing with material with a low melting points, and so on. Instead of joining it, you are bursting it into a hole because too much heat is being supplied. Okay, and if the voltage is too low, sometimes it's not good as well, because some of the material or the parent material here has a very high melting point, and you do not generate sufficient heat, then the welding will not happen as well. Okay, so this one, how much you need to be setting, and so on, you need to refer to the manual or to the welding manual. They will tell you if you are using this grades of materials, this grades of material is having such and such melting point, you must set it to, let's say, 50 volt or something like that. Okay? Then to ensure you that this welding method actually happens in a more perfect way. All right?
Operations also apply pressure on the workpiece during the process for better weld quality. Most arc welding processes.
And also, when you are performing this kind of welding, a shield is always recommended that you must use it. Because as we see from the video, that when we see from the video, yeah, it's okay. But when you are at that place, when you are doing this welding, that amount of intensity is going to blind you. But of course, you do not get blinded, immediately. But after you see it for a prolonged time, when you try to look at something else, it will be something like you'll be something like temporarily losing your eyesight, and something like that. You see, everything is totally bright, and white, and so on, and sometimes with like spots, around. So that might not be good for your eyesight, and for as well. Okay, so you do not want that, to happen. So that's why you need to have a protective shield. All right. So this protective shield actually help reduce the intensity of the light. Okay. So in the end, all right. So it makes your eyes more comfortable. It do lesser harm to your eyes, and so on and so forth. All right. So whenever you are happen to come across, people doing welding works, and so on, and do not actually look directly into it in a close range. It's not good for you. And also, you can see that there are smokes coming out here. So those were actually somehow quite toxic. All right. So prolonged inhalation of it might actually cause, problems for your health. All right.
Utilize a filler metal. The second type of fusion welding is gas welding. In gas welding, a strong, high-temperature flame is generated with the help of flammable gases. The flame is used to generate heat and raise the temperature of the metal piece at the place where the joint.
So this is another welding method that is that we'll discuss later stage in this fusion welding. This is by using the chemical combustion. It's a mix of chemical, okay, by the use of let's say this oxyacetylene, okay, gas, okay, so it's a hydrocarbon base, okay, so with a mixture of oxygens, and so on. So to create this kind of flame, okay, that is used. So there are advantages in this, which we'll discuss later. But however, I can tell you in first hand, that with this method, basically we can perform this welding in anywhere, which you can think of. Like for example, in the fusion welding, the only thing that is required is one of these, of course, the toolings, the welding torch, and so on. But the one thing that mustn't miss, must exist is the electricity. Now, if let's say you are building a factory, and so on, in the middle of the jungle, and so on, or in the middle of the jungle, you want to perform a welding, so where are you going to find the electricity? That will be questionable, right? If you have a generator, and so on, that is fine. But if you don't have that, now pretty much you cannot do anything, right? But with this gas welding means that you just need 2 cylinders of gas, which is the oxyacetylene and the oxygen and the torch. So you can actually perform it anywhere as long as the supply of gas doesn't run out. You can perform the welding process. All right.
Joint is to be made. Due to the heat from the gas flame, the metal at the joint starts to melt. The molten metal is then joined to another metal workpiece. A filler material is also added to the molten metal to act as a binder. The molten joint is then allowed to cool and solidify. Many different combinations of gases is used to obtain a heating flame. The most common being oxygen acetylene flame. The third type of welding is thermite welding. In this type of welding, a thermite compound is used to weld two metals together. Thermite is a type of chemical composition of a metal powder. The powder normally consists of a metal and a metal oxide. When ignited, it undergoes an extremely exothermic redox reaction. Here, the oxide from one metal transfers to the other metal. In this process, a huge amount of heat is generated for a brief period. Thermite welding is mostly used to join rail tracks in railways. This was done as it required almost no heavy machinery and is very fast. This welding process is also used to repair rail tracks as the molten metal from the reaction can be used to repair the tracks. Well, that's it for today's video, guys. In our next video, we'll have a very brief discussion on each of the individual processes we have talked.
Okay, so this is more or less about this fusion welding. So we move on this to this thing called the arc welding. Okay. Okay, we move on to this. Okay, we move on to the animation first before we see the real thing.
Nani, nak satu bungkus campur daging boleh tak?
Principle of arc welding. Now we are going to see about the principle of arc welding. The arc welding consists of arc welding machine.
So this is this power source, all right? So this power source, of course, is going to go to the wall plug, and so on. So normally it's a three-phase. Three-phase is about 315 watt, I think. All right. So here are some controller, and then the plus minus, and so on. All right. For this control, okay, control button, the on-off switch, and so on.
Work lead, electrode lead.
So the plus minus one would go to this torch, and one would be ground. Okay, so to complete the circuit, so there is a complete the circuit, so that this spark will actually jump from these tips of this rod, okay, to the parent material. If this is not being connected, there won't be any jump of sparks from the tips to the parent metal. All right.
Electrode holder, flux coated electrode, clamp, and metal plate.
Right, it mentioned here just now there is a flux coated electrode. Now, why do we need a flux coated electrode? Okay, let's move back to our notes. Okay, so let's say if we have this parent metal, if we have this torch, all right, and we have this filler rod, the rod here, so it will create a sparks. Okay, when this electron jump from these tips to this parent metal. So as a result of that, this thing will melt and start sitting on top of here. As I mentioned that, okay, as I mentioned just now that the cancers of the metal is oxygen, right? So there will be, you can't ignore it. Oxygen always, exists, in our ambient. So this oxygen will tend to want to actually react with this molten metal, okay, to form oxide. So the purpose of having this flux is that when, let's say, this thing is melted and seated on top of this parent metal, so inside there, okay, consists of metal and flux, okay. So in the end, The design is that the flux is having a lesser density. It's less denser than the metal. So the flux will be floating on top of this metal so that it creates just a phenomena whereby the metal or this heated metal or the molten metal is actually being covered by flux. So the oxygen, if you want to attack, you attack the flux. You do not attack the metal. Okay? And in the end, when everything is cooled down, I just chip off the flux, and so on. So whatever remains is a white, shiny, good, without oxidized metal layer. All right? So it creates something like a protection, okay, over the welding area to prevent oxidation from happen. All right?
In arc welding, the electrical energy is converted into heat energy. The current passes through the workpiece and the electrode, which produces an electric arc. Due to the heat developed, both the electrode and the base metal get melted. The electrode and workpiece brought nearer with a small air gap of below 3 mm approximately.
So you can see that this electrode here is actually moving closer and closer and closer. So you need to have a very steady hand. You need to have a very steady hand that move, your hand is some of the people like myself. I have a shaky hand, all right? The hand will be tends to shake a little bit, so not so steady hand. So now, if I want to become a policeman, I will fail. Instead of shooting the suspect, I will be shooting the victims. so in the end, this kind of a little bit of variation, sometimes you miss the target, right? So in the end, I might not be so suitable for this kind of job because this steady hand is very required. All right. So that's why, for example, for a professional welder, and so on, or now and then they need to go for this test, to see that whether they are still fit to become a professional welder. So as you know, when people gone aging, and so on, so their physical condition change, some of them might have this kind of Parkinson disease, and so on. But of course, I must declare that I do not have Parkinson disease yet. Okay, future I don't know. But my hand is a little bit shaky, okay? Once I'm holding some things, and so on, especially that needs precision. So I can see that my hand actually is moving, vibrating in a very minor manner. So I don't know if it happens to everybody else, but it happens to me, right? So which makes if I will to perform a welding, I can still do a pretty good job, okay. But still, I will feel that if without this, I can do an even better job, right?
Slag protects the weld pool from oxidation and heat loss, that is slow cooling. Slow cooling avoids distortion and brittleness of the joint. In previous video, we have seen the principle of arc welding. Now, we are going to see the general setup for the metal arc welding. The metal arc welding consists of arc welding machine, electrode holder, clamp, electrode lead, work lead, negative terminal, positive terminal, and electrode. The work is connected to the positive terminal of a DC welding machine. The electrode lead is connected to the negative terminal of a DC welding machine. The electrode holder carries the electrode. the general setup of arc welding. The sequence of steps involved in arc welding is explained in the next video. Sequence of steps involved in arc welding. Here, we are going to see the sequence of steps involved in arc welding. The arc welding consists of arc welding machine, electrode holder, clamp. The leads are to be connected properly to the power source. The electrode is connected to the negative terminal of a DC welding machine. The work is connected to the positive terminal of a DC welding machine. The edges are to be cleaned with wire brush.
Okay, I mentioned here that it has to be clean, right? So, in order to have this arc welding, okay, being done in the most perfect way, you have to weld on a very clean surface. Okay? A surface that is clean from rusting, clean from oxide, clean from oil and grease, so that to make this electron jump from the stick to this parent material happen in the most perfect way, or else it will be hindered. Some of them spark successfully, some of them didn't because of the blockage, because of the obstacle from this oxide level, rusting, grease, dirty, and so of course this painting on top of the surface, and so on. So it will actually hinder this whole arc or the fusion welding process.
Striking the arc, the tip of the electrode scratches on the parent metal. After scratching the tip of electrode for a moment, a gap of 3 mm, that is approximately, is to be maintained. The electrode should move along the length of the joint, maintaining the arc and avoid the distortion during welding. At the end of the run, slag coating present on the bed is chipped off.
You can see that they're using this kind of hammer of the teacher to actually remove this slag, okay, that is covered on top, like how I discussed with you, the blanket that used to protect the welded area from oxygen, okay, it is being chipped away, all right?
And then the area is cleaned with a wire brush. Two dissimilar metals are joined by using arc welding.
很多人问我，窗帘这样难做，为什么拿做你可以持续那么久？我讲啊，我做对了很多个东西。
Okay, for the last thing today, we're going to view this video. Okay, this is the real demonstration of this arc welding. Okay, and after that, we are done for today. All right.
This welding rod fits into an electrode holder, which is insulated and allows the operator to safely hold the electrode without danger of receiving an electric shock. The rod can be positioned in the holder in a number of different ways, depending on operator preference or the position of the work being welded. When the welding machine is on and the ground clip is connected to the steel table or to the work itself, anything metal on this table is now charged. When the electrode makes contact with the work, it completes a circuit. The electricity flowing through the electrode holder, down through the work, and back out through the ground clamp back to the welder. When an arc is struck, a common pool of molten metal is created between the two pieces that are being joined. Into this, the melting alloy center of the welding rod is deposited, completing the weld. One thing to be careful of, as you're welding, this rod is being consumed. That is, it's growing shorter. So that the operator has to constantly be aware of both moving the rod laterally, but also pushing the rod into the seam being welded. The first step in learning how to arc weld is learning how to strike the arc. Striking the arc can sometimes be very difficult at first. It's a delicate flicking motion. It's not a stabbing or a quick drag, but as if you're striking a match gently. Once the arc has started, the trick is to maintain a nice smooth molten puddle of metal with a consistent distance between the tip of the welding rod and the surface of the work. All right, let's give it a try. Welding hoods down. Remember, never look at an arc with the naked eye. Now that you've mastered striking the arc, and it may have taken you several tries, don't be discouraged. Let's join some metal together. Okay, hoods down. After striking the arc, I create a nice, even pool of molten metal. You'll notice that the tip of the welding rod stays very near to the arc puddle, and that I'm also slightly wavering the tip of the electrode back and forth. The idea is to heat both pieces of metal evenly as the filler rod is being deposited. Once you've completed your arc welded seam, you'll notice that there's a blue-black residue on top of the weld. This residue is the byproduct of the burning flux. It needs to be cleaned away from the weld. You can do this with a chipping hammer, and wire brush.
All right, I think that will be all for today. So we will continue more on this arc welding in our next class, which will be on Monday next week. All right, thank you very much. Thank you for your attention. Have a nice day. Have a nice weekend, and have a nice Christmas. Merry Christmas.
Thank you, Doctor.
All right.
Thank you, Doctor. Merry Christmas.
Merry Christmas.
Merry Christmas.
Thank you.
Thank you, Doctor.
All right, thanks.